So for part three, we're going to discuss nutrient and water management. We'll start with fruit tree nutrient requirements, then we'll get into water requirements, and we'll also explore the benefits of compost and mulching for nutrient and water dynamics. So starting with nutrient management, as I'm sure you all know already, all plants need certain elements to function. So in one category, we have macronutrients. So these are the nutrients that plants need in larger quantities. So this means, for example, nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium. And if you ever hear people say NPK, they are talking about nitrogen, phosphorus, and potassium. The K stands for potassium, which can be a little confusing. So NPK, just think your three big macronutrients: nitrogen, phosphorus, potassium. In addition, plants also need micronutrients in much smaller amounts. So micronutrients include things like iron, manganese, copper, zinc, molybdenum, boron, chloride, and nickel. Plants really don't need a ton of these micronutrients, but they need at least a little bit in order to function fully and be healthy. And so all of these macro and micronutrients come from soil, fertilizers, amendments, inputs that we add as well. At the same time, of course, plants are getting carbon from the atmosphere and hydrogen and oxygen from water and air. So I wanted to describe something called the law of the minimum, which comes from ag science, and I think it's relevant in the backyard setting as well. So this just means that if one of these essential elements is low, plant functioning and yield will be low until that deficiency is lifted. So this is usually represented as a barrel metaphor. So let's say you've got a barrel, it's full of water as pictured here, and there are these different staves, the wooden planks that are different heights. And so the idea here is that the lowest stave represents the most limiting nutrient. So in this case, in this barrel, we have potassium as the lowest one. So it's really limiting the amount of water that can go into this barrel, or in other words, it's limiting the amount of yield or the amount of fruit that you can get off of your fruit tree. So it doesn't matter at this point if you added more nitrogen or more sulfur. It's really not going to affect yield at all or plant health. What the plant really needs in this case is potassium, and then that will lift the limit of this barrel in terms of yield capacity, but also just plant health and functioning. So this is important because we need to address the real problem, the biggest limiting factor. So let's say we did that and we supplied the most limiting nutrient. This is going to lift that yield potential to the next most limiting factor. So in this case here, it looks like nitrogen is the next lowest one, but it's worth mentioning that sometimes water is the most limiting factor. So that's a good thing to bear in mind as well. So another really important concept around nutrient management is thinking about how, here we have on the x-axis horizontally, we've got the concentration of a mineral nutrient in plant tissue. So let's just say potassium again for an example. So it's small on the left, increasing as you go to the right, and then on the y-axis we have plant growth or yield. So you can think about this as the amount of fruit you get off your fruit tree. So if we're thinking about the plant tissue now, so we're moving into the plant and we're thinking about, okay, how much potassium is actually in this plant? We have this curve, and this curve starts with a deficiency. So let's say concentration's really low, the plant's struggling, but at some point you're adding more potassium. Let's say you put down some fertilizer and you reach this adequate range where there is actually sufficient potassium in this case in the plant tissue for plant functioning. You're going to see increases in yield and fruit. However, you can apply too much. And this is especially relevant for things like boron, nitrogen, some nutrients. It's kind of a little more finicky and you can apply too much of something. So that's when you get into this toxicity range where too much is just not good for plant health either. So you really want to be in this adequate range or Goldilocks zone. So deficiencies impair plant functioning and production on the one hand on the left, but over-fertilizing, also can lead to some problems like too much vigor with nitrogen. If you ever over-apply nitrogen or the plant has access to too much, you might see an increase in foliage, sometimes too much foliage at the expense of fruit tissue. You might also see reduced yields and quality, so this does affect the fruit as well. And you can cause some environmental damage with this as well. So if you're over applying nitrogen, for instance, nitrate, which is a form of nitrogen, is pretty mobile in the soil. And if you get a big rain event or a big irrigation event, you can flush nitrate out of the soil profile and into groundwater, which is not good because it can cause environmental damage, but also human health risks as well. So it's just good to think about, you don't want to apply too much because you'll lose it in some cases. It could potentially cause some damage, but you're also just wasting money, and fertilizer sometimes can be a little expensive. So you really want to be in this adequate range where, the plant can function best. So you can think about this like the safe zone, not too little, not too much. So nutrient management decisions are really important, and they impact all kinds of things like tree health and yield, like we just talked about, but they also impact soil. So your decisions around nutrients impact soil stability, erosion, the microbial life present, other biological life, nutrient cycling. Nutrients influence agroecosystem health and regional environment as well. They influence groundwater quality and human health and greenhouse gas emissions. So there's a lot of effects and implications here since we're working with biological systems. So I want to introduce this concept of nutrient use efficiency to help us think about this. So this just means what percentage of the applied nutrients are actually taken up and used by the tree. So this is just something good to have in the back of your head. How do I make sure that, the highest fraction possible is actually used by the tree and doesn't, leach off site? And I like thinking about it with this nutrient budget approach, which is, again, a concept borrowed from agriculture, but I think is really helpful framing. So this is just saying you want to replace the amount of nutrients that you export at harvest. So let's say you have a small crop year, maybe you only get, a handful or small amount of apples or whatever fruit. You really don't need to apply quite as much to replace that, assuming you're at a good level. So assuming you're in that safe range, if you get a small crop, you're exporting those nutrients in that crop off site. Whereas let's say you have a huge tree, a lot of yield, you're in the safe range, you're going to need to replace the nutrients that were in those fruit every year. So that's just something to bear in mind. We just want to make sure we're in the safe level and then use this budget approach where we are replacing the nutrients exported at harvest. And this is really going to help us maintain optimum status of nutrients for plant function and health and also fruit production. So our goals with this are supplying enough nutrients to meet crop needs and optimize plant function. We want to minimize environmental impacts. We want to minimize off-farm inputs as well and integrate in recycled biomass when possible. So you might use a little fertilizer. You might also use some compost. And we also want to be economically efficient as well. So thinking about deficiency symptoms, there's some characteristic ones, which are nice. Sometimes, it's easier to tell, oh, that's probably a nitrogen deficiency. And sometimes it's kind of hard to tell, but I think going through these characteristic symptoms is a really good foundation and will help you think about how to go about diagnosing issues in fruit trees. So in general, nitrogen deficiency tends to be the most common nutrient deficiency across the board. So you're going to see light green foliage. So if I use the word chlorotic, or if you ever hear that again, that just means it's light green, it's kind of yellowing. It's not as dark green as it should be. You also probably see poor shoot growth or maybe smaller leaves. Nitrogen deficiency can reduce growth overall in the tree, fruit size, and yield. So at the bottom left, we've got some nitrogen deficient cherry leaves, which are pretty pale yellow. And then we also have apple leaves that are deficient on the right, which is pretty pale yellow. So these leaves should be a lot darker green. This is a nice characteristic symptom of nitrogen deficiency. It's also worth noting that sometimes you can get transient nitrogen deficiency in the winter. So for trees that don't lose their leaves, such as olives, as pictured here, but also with citrus, you're going to see that chlorosis or that leaf yellowing in the winter when nitrogen's not really that readily available. So there might actually be some nitrogen in the soil, but because the roots aren't actively taking it up, sometimes you can see these deficiency symptoms appear in the leaves. But the good news is a lot of times this tends to be transient. So deficiency symptoms kind of disappear when root activity ramps up again in the spring and nitrogen uptake increases throughout the spring and early summer. So sometimes this is transient, thankfully, but other times it's not. So that's just a good thing to bear in mind. So going more into some symptoms here for more examples, we've got that chlorosis again occurring in winter when nitrogen is not available. But as I mentioned, it might pick up again in the summer. So here we've got citrus leaves. This is also common in citrus. I know I've seen it, both in commercial orchards, but also just in backyard gardens, including my own. This happens in the winter. And you can apply fertilizer. You can also wait and see if it corrects itself if it's not a really severe issue. So these are just more examples of nitrogen deficiency. On the other hand, you can also have too much nitrogen. So nitrogen excess can lead to too much foliage, really dark green leaves. And this basically indicates, you're probably over applying nitrogen. You're not really using nitrogen in a particularly efficient way. And if you're applying a ton of it, it's, you have potential to lead to nitrate leaching, which we want to avoid. So here's just, the spectrum. We've got healthy foliage in the center here, chlorotic leaves like we've seen lately for deficiency, but then on the left, that abnormally really dark green foliage from excess nitrogen. There's also more leaves on that branch. So that's just something to look out for. So nitrogen excess, applying too much fertilizer with nitrogen is a pretty common mistake that often reduces yield quality and quantity. So, just wanted to mention, this is also a concern just in terms of balancing out that vegetative growth with the fruit growth as well. And this just is a nice example with olive trees where we've got nitrogen level on the x-axis, and we basically see that yield increases to a point, but then kind of plateaus and goes down with more nitrogen. So again, there's that sweet spot in the middle where you do have enough nitrogen for the olive tree in this case, to function, produce good yield, good quality, but too much does cause problems. Okay, so now we're going to switch to potassium. So potassium deficiency, sometimes tends to be much more common in sandy soil because sandy soil doesn't retain potassium quite as well as like more clay soil or even loam. So in sandy soil, there's a lower cation exchange capacity, which I'll explain later if you're not familiar with that. But essentially, sandy soil has less parking spots for cations. Potassium is a cation. So in sandy soil, potassium tends to move a little bit easier through the soil profile. Usually potassium deficiency isn't quite as much of an issue in clay soil. So that's just a site-specific thing to bear in mind. So generally, potassium deficiency leads to intraveinal chlorosis. So that just means yellowing between veins in some cases, scorched leaf margins and tips. So we see a really good example of that on olive leaves on the bottom left. It can lead to leaf cupping and curling like we see on the bottom right, shoot dieback, and small fruit. So those are some potassium deficiency symptoms on fruit trees. Moving on to zinc. So this one also sometimes happens in fruit trees. Zinc deficiency leads to little leaves or rosettes. You can kind of see what that looks like in the bottom left corner here, where we have these little clusters or rosettes of tiny leaves, much smaller than they should be. You can also see in the picture next to it, we have areas of the branch without any leaves, which is not good. That's another symptom of zinc deficiency. And the two photos on the right, we see really great visual symptoms of zinc deficiency with that intraveinal chlorosis. So this just means, the veins remain green, but we've got the areas between veins and along the edges have become pretty yellow. So if you see stuff like this, there's symptoms of zinc deficiency. It's a good way to start thinking through what might be causing problems. So moving on to calcium, if you have a calcium deficiency in apples, sometimes that leads to something called bitter pit, which kind of looks like a disease, as you can see on in the photo here, but it's actually a calcium deficiency. So this can be related to low water uptake and therefore low calcium uptake. So, kind of similar to nitrogen, like we talked about, if the tree's not taking up enough water, it might show signs of nutrient deficiency, such as calcium. So there might be plenty of calcium in the soil, but if it's not being moved from the soil up to the plant through water, sometimes that can cause deficiencies, even if your soil test tells you you've got plenty of calcium. So something to be aware of. And on the fruit here, we see depressed areas on the fruit surface, these sort of small brown corky areas within the fruit. Moving on to iron deficiency. So in citrus, this appears first on young shoots. You're going to see intraveinal chlorosis and that necrosis as well. Here's what that looks like. We've got pale leaves, and the veins remain green in that bottom photo, especially in that bottom photo. So these are some iron deficiency symptoms. And we have boron. So boron is an interesting one. So boron deficiency in apples looks like misshapen fruit with that corking. Again, so you can sort of see that in the bottom left, where we've got, those brown corky patches within the fruit tissue. Boron deficiency also leads to small leaves. It can reduce shoot growth and also reduce fruit set. So boron's a little tricky because plants need it in a very small amount, but if you apply it in fertilizer, you can easily over-apply it. So that's just something to be aware of, making sure you apply the correct rate, which we'll talk about now. So thinking about nutrient requirements, you want to ask yourself some really important foundational questions. So how much or what rate, what type, when do I apply it, and where do I put it? So we're talking about rate, source, timing, and placement. And this is just an example of product that a home grower could buy. Definitely not an official endorsement, just an example. There's a lot of different products out there, and I highly recommend exploring lots of different options, making sure you choose what's right for you. So we're going to get into rate, source, timing, and placement in a little more detail. But the best thing you can do, most important thing, is to always read the label for your chosen product. So like I mentioned, there's a lot of products out there, and they often have pretty different formulations, ingredients, directions. So it's just really, really important to read the label for the product that you choose, because different products have different instructions. But all of this information, rate, source, timing, placement, will be on the label. So best place to start is just make sure that you know the correct way to go about applying it. So getting more into this, rate really depends on the plant's demand and the product ingredients and instructions on the label, like we just talked about. But the goal is really just replace the nutrients exported in the fruit and stay in that safe zone. Thinking about source, you have, two big general broad categories of organic or synthetic. So sometimes people say conventional, synthetic, essentially it means the same thing. And you're going to think about placement. So this could be over tree roots and within the irrigation zone. So you want to make sure you're putting it in the spot where the tree roots will be able to take it up and access it. And you want to think about timing. So we really want to match nutrient availability with the timing of plant nutrient demand. So this usually means spring, summer, making sure that those nutrients are available right at that time when the plant needs it the most. So thinking about, first steps in going about correcting deficiencies, in general, applying a little compost is a great place to start if you think there might be a deficiency, because compost usually contains a lot of different nutrients. So this can kind of be a quick fix in some cases, and it's a nice, easy, convenient way to start. Also, there might be enough nutrients in the soil, but if conditions are really cold, like I mentioned in the winter, or the soil is just too dry, there might not be much uptake happening by plant roots, since nutrients travel via water in solution in the soil, and plants take them up in solution. So going more to different sources, we're going to start with organic sources, meaning these products are coming from materials that at some point were alive, living organisms. There's a ton of different commercial organic fertilizers out there. I didn't even attempt to try to summarize the different nitrogen, phosphorus, and potassium concentrations. There's all kinds of options. So that's the good news. You can go and find exactly what you need. You can always just start by talking to your local garden supply store and seeing what they've got. You can also order things online. But because, I know this is of a lot of interest to some people, what else can you use besides fertilizer? And in fact, some fertilizers are actually made of the following materials. But just thinking about, what these things really contain, we have other organic sources like fish meal, fish emulsion, kelp dry meal, blood meal, bone meal, feather meal. So you might see things like this appear on fertilizer labels or just product labels. So just, for some general estimates, you might find fish meal, blood meal, feather meal tend to have higher nitrogen than some of these other products. Whereas, thinking about potassium, bone meal has really high, or phosphorus, my bad. So in the P column, we've got phosphorus. Bone meal has relatively much higher phosphorus. And with potassium, we have fish meal and kelp dry meal have a little bit higher potassium than some other products. So, if you're really looking for a source of nitrogen, you can compare and see how much you're getting within a given product. And this sort of information is going to be on the label. Some more examples, we have fresh poultry manure, composted rice hull or poultry manure, fresh dairy manure, composted dairy manure, and composted olive pomace or grape pomace in some cases. So these are all just, different sources that you might have access to one way or another. And again, these are really broad estimates, but generally speaking, you're going to see pretty high and a relatively higher nitrogen in like fresh dairy manure and poultry manure, definitely. And, you might see a little bit higher potassium in composted rice hull, poultry manure, and dairy. So this is just to give you broad ranges, what you might expect. So now we're going to go into timing a little bit more using the example of apples. So we're going to talk about rate and timing over the course of 2 years. So let's say you plant an apple tree and in year 1, you want to do a light nitrogen application. So this might mean around 0.5 to 1 ounce of nitrogen total after you see 6 to 8 inches of new growth, and you're going to split that into 2 applications just a couple months apart. So the idea is we don't want to overload this tiny young tree with nitrogen, but we do want to make sure it has enough to grow. So we're going to split this application into 2 different events. So this makes sure that we're not dousing it in more nitrogen than it needs. And then in year 2, we're going to do summer applications. So let's say 1 to 4 pounds of nitrogen per tree annually in the summer, split into, again, several applications, and make sure that that is accompanied by irrigation, since like we talked about, nutrients need water to move up and into plants. And the important thing with splitting these applications of nitrogen is just to make sure you're essentially spoon feeding the plant what it needs at the time it needs it and not overloading it all in one event. It's important to just be aware that nitrate leaching can happen. And so we don't want to over apply water and flush out all that nitrogen out of the root zone. So make sure you're not over applying. You definitely want to make sure you're always monitoring for irrigation leaks. And thinking about other nutrients, you want to maybe occasionally apply a well-rounded fertilizer or compost to supply other nutrients that these trees will need, like phosphorus, potassium, magnesium, calcium, and the other ones that we talked about. So just be aware, you could do an occasional well-rounded fertilizer application as well, just to cover the bases. So thinking more about timing, I really want to stress that the timing of nutrient availability should match the timing of crop demand. So this is true, in all tree crops. So using olive just as an example, we're going to think about olive phenology. When do they really need available nutrients as they're changing and developing throughout the season and throughout the years? So mainly we want to apply in the spring and summer. So we're going to make sure nitrogen is in the root zone right before uptake in the early spring, as you can see with a green nitrogen in the arrow. So this is just ahead of shoot growth and bloom. And then we can apply some potassium, some boron if needed in the winter, so that rain helps move it into the root zone for spring uptake. But I really just want to emphasize that, you might not really need to do the potassium and boron. It just depends on plant demand. And I would just focus with olives on making sure they have enough nitrogen in the spring and summer. But it's also really easy to over apply nitrogen as well. And that leads to, like we talked about, excess foliage. So again, always make sure you're following the label and not applying too much of anything. If you're interested in the crop production or agricultural perspective on these things, let's say you have a small backyard orchard, you can check out the California Crop Fertilization Guidelines. So this is a really excellent website developed by UC Davis and CDFA. This just really shows a lot of nice visuals around what's going on with nutrients in fruit trees over time. So if for nothing else, they have great visuals, and it really helps illustrate different nutrients demands for different specific types of fruit trees. So I use this a lot as a handy resource. And it also has, information about how to do soil tests or leaf analysis, and just how to understand what's going on with nutrients. So this is more agriculture focused, but I think it's a really nice visual tool and could be relevant for folks who are interested in exploring that. Okay, so now we're going to go into soil management a bit more. So we're going to start with soil organic matter. So soil organic matter is that material in the soil that's derived from living organisms. So basically, soil organic matter is just a bunch of different forms of soil carbon at different stages of decay. And so that's represented here as these little soil organic matter sort of rounded blocks in green. They tend to be negatively charged overall. And also soil aggregates and mineral surfaces tend to have an overall negative charge. So this means that you've got, different forms of carbon stuck onto these soil aggregates and mineral surfaces, and they contribute to that overall negative charge of the soil. So over time, if you apply organic matter amendments, and you also use other practices too, like, reduce soil disturbance, maybe cover crops, you're going to see an increase in soil organic matter, which is what we want. And that's great because essentially you're increasing the parking spots or cation exchange capacity, like I mentioned briefly earlier. That helps create more spaces for cations to come park and wait for plants to use and access. So this is really nice because it helps increases the soil capacity to hold on to cations. So soil organic matter promotes nutrient cycling as well in the root zone, in a lot of other ways too. But this is a relevant one, especially if you're in sandy soil, maybe you're leaching potassium. Increasing soil organic matter can help to some degree. CEC is also an inherent soil property, so sandy soil is just generally going to have lower CEC than clay soil, and that's okay. It just means you want to bear in mind when and how much you apply cations, that kind of thing. So just more stuff to bear in mind. Thinking about big picture principles, we want to start with a really nice, well-rounded fertilizer approach that meets the tree's basic needs. So that means the right source, rate, timing, and placement. You can always check the label if you need to. But we also want to build soil organic matter. So that means adding organic matter amendments like compost, keeping living roots in the soil like cover crops, keeping the soil covered as much as possible. Mulch is great for that, and minimizing soil disturbance. So overall, with nutrients, we just want to be thoughtful and responsive, and not too prescriptive because, different trees need different things in different contexts and different soil types. So now we're going to move on to irrigation management. So regular irrigation is needed for good growth conditions and healthy fruit trees. So you want to supply water to prevent damaging tree stress. So a little tree stress might be okay, but at some point it reaches a threshold where it becomes really damaging to the tree itself. So a great thing to do, I always circle back around to genetics. So if you can start by choosing cultivars that have relatively low water requirements that you know you can meet, that's, in my opinion, the best place to start and a great policy. So just be aware of how much water you have access to and will have access to in the future, since a fruit tree is a long-term investment. So just make sure that you know you can meet their needs with water. So that's the first question you want to ask yourself is, do you have enough water to meet their needs? And then you can start thinking about the water needs of your crop by asking, okay, how much, how often, that kind of thing. So a really helpful concept with this is evapotranspiration, or ET, as you might hear it abbreviated. So ET just means daily water use. So ET is equal to the amount of water evaporating from the soil surface plus the amount of water that is used or transpired by the tree. So here's what that looks like. We've got water evaporating from the soil surface, and we have water being transpired by the tree into the atmosphere. So in both cases, water is going into the atmosphere. So an important point is that water use by fruit trees is actually relatively similar between species overall, and relatively more different between size. So small trees are going to have, much less water needs compared to larger trees. And of course, water use is also profoundly influenced and dependent on climate conditions as well. So for instance, on a hot summer day that demands, let's say, a 1/4 inch of water, a 6 by 6 foot tree would use, let's say, around 5 gallons of water that day, whereas a 10 foot by 10 foot tree would use more like 15 gallons of water daily. So that's a pretty big difference. And here are just some arrows to symbolize that. So different tree sizes will have different ET and water needs. And this is another reason why I always circle back around to pruning and cultivar selection. I'm a big proponent of relatively small, manageable trees for a lot of reasons, and water use is one of them. So drought stress can also permanently damage trees and reduce tree health. So I think this is an important point where, sometimes it looks like trees recover, and they do in some cases, but severe drought stress does cause embolisms. So embolisms just means these tiny air bubbles in the xylem that form. You can think about it as like hydraulic failure, essentially, where um, these air bubbles in the leaf vein happen because these trees are so drought stressed that they cause these breaks in the water column. And this prevents transpiration, it prevents water movement throughout the tree, and it permanently damages plant cells. So they can cause pretty serious damage, especially if you have severe drought stress year after year. So this is just something to bear in mind. There are repercussions to plant health. So some visual symptoms of drought stress include this loss of turgor pressure. So turgor pressure is essentially just the positive pressure within a leaf due to water that keeps leaves relatively upright. So, the way that they should look. Whereas if you have, really severe drought stress or even sometimes moderate drought stress, you might see wilting, and that's just that loss of that positive internal pressure. So if you hear turgor pressure, you can think about, that just means wilting. It also can cause marginal necrosis, which is a symptom of other things we talked about too. So sometimes it can be easy to confuse that with other causes, but if you do have pretty severe drought stress, you'll likely see marginal necrosis. It can lead to bark cracking, like we see on the far right here. This is a pretty severe case. Unfortunately, this was a very young seedling. It got very drought stressed and has some pretty severe bark cracking. The drought stress can also lead to stunted growth, defoliation, and tree death. So just be aware of the repercussions of not irrigating enough really do compromise tree health, and of course, how much fruit you get from your tree. So another thing to consider is soil texture. So soil texture influences the soil's water holding capacity. Clay soil is generally going to hold onto water more than sandy soil will. So it's important to know your soil type and how it affects water movement throughout the soil profile. You can use that web soil survey that I mentioned earlier, or you can just dig down and see how far the water infiltrated into the soil. Of course, that takes some time, and you probably don't want to do that too often, but if you're ever curious, that can be a nice way to really just visually see how far water is infiltrating. So I'd highly encourage everyone to consider using mulch. If you're not already, mulch is great. It improves water infiltration. So it's basically this physical barrier on the soil surface. Um, and it helps slow down the movement of water a little bit, which helps with infiltration into the soil beneath it. It also, as a barrier, reduces evaporation from the soil surface. Like we talked about that component of ET earlier, you're always going to have some amount of water evaporating, but mulch creates this physical barrier which reduces that evaporation, which is very helpful. And that can actually help maintain soil water content beneath it. So by doing this, it helps keep more water in the root zone where the plant roots can access it. And of course, also it can suppress weeds, which just means less competition for water by the tree. So thinking more about irrigation, you want to consider too that most roots are usually concentrated in the upper 2 or maybe 3 feet of soil. So you really don't need to irrigate too much deeper than that. Drip tape, drip irrigation is more efficient than sprinkler irrigation or micro sprinklers. So this is great. Drip is a really great resource, a tool to use. So with drip tape, you're going to have less water loss due to evaporation, and you're really only going to provide what the tree actually needs. So I'm a big proponent of drip. So now we're going to move into organic matter amendments and talk about how they influence nutrient and water cycling in a little more detail. So I'm going to abbreviate it in these slides as just OMAs. They are soil amendments that come from something that was alive at some point. So this is opposed to inorganic amendments like chemical fertilizers or the synthetic conventional fertilizers I mentioned. So examples that you're probably familiar with are compost, wood chips, leaf mulch, straw, grass clippings, etc. So these organic matter amendments are used to provide nutrients for plants, create that mulch layer that I discussed, and generally promote lots of different components of soil health. So I'm going to talk about soil health in a little more detail because sometimes this phrase can be a little ambiguous. So when you hear someone say soil health, they're talking about 3 categories of soil functions. So chemical, biological, and physical. And usually soil health tends to emphasize that biological component. So microbial life, worms, anything alive in the soil. But it's important to remember that, soil health encompasses all 3 of these categories of functioning. So what does this really mean? As some examples of indicators of these different functions, soil chemical indicators include pH, CBC, available nutrients, all the nutrients we discussed that are essential for plant functioning. When we're thinking about soil physical properties, that's more structural. So we're thinking about bulk density or infiltration, the capacity of the soil to hold on to water, the stability of soil aggregates, and that kind of thing. And then we're getting into biological, then we're talking about microbial biomass, microbial community composition. So that just means who's there and what are they doing, and of course, earthworms and things like that. So, this is really important. These different functions are super important in the soil because they influence the plants above them. So soil chemical components govern nutrient supply for plants. Soil physical components govern aeration, water availability, soil water dynamics for plants. And soil biological components help improve these other things. So the biology of the soil can help improve soil chemical and physical functioning. Some microbes form mutualisms like mycorrhizae that really help plants, and some microbes can help suppress plant pathogens as well. So there's lots of benefits of these different soil health functions for plant function too. And of course, I'm representing them as separate things, but in real life, chemical, physical, biological components of soil health are all overlapping, interlinked, but it's easier to present them in these 3 categories. So just bear in mind, in biological systems, all of these things are interconnected. So the idea here is, functional soils lead to functional plants. Organic matter amendments can enhance soil and plant functioning in all of these categories. Some benefits happen really rapidly while others take more time. And like I mentioned, soil health, that phrase really tries to integrate all three of these functional categories, and it emphasizes that biology and the soil's capacity to sustain life. So just thinking about, what can you generally expect when it comes to these benefits and effects of organic matter amendments? This is, again, broad and general, but in the short term, you can expect some benefits that I'll get into in a moment. But in the long term, you're going to see that if you, layer or stack or integrate soil health practices like organic matter amendments, lower disturbance of the soil, root exudates from cover crops, these practices combined really increase soil organic matter. They all can do that individually too, but you're going to see more increases in soil organic matter if you combine lots of soil health practices, but that's a long-term thing. In the short term, a low carbon to nitrogen ratio organic matter amendment, so that just means an amendment that's got, let's say, 20 parts carbon to 1 part nitrogen. So that would be relatively low. It might be compost, for instance. That's going to provide more plant available nitrogen than a high C to N ratio amendment, something like a mulch, where there's just really not a whole lot of nitrogen in wood chip mulch. That's going to more gradually provide nitrogen. It's not going to be a ton of it, just a little bit. So, thinking about nutrients here in these green boxes, in the long term, though, lots of different organic matter amendments can help moderate pH or improve CEC and improve nutrient availability in the plants. If you just need nitrogen in the short term, though, you want to find a low C to N ratio amendment to provide plant available and in a timely way. Thinking more about soil structure in the blue boxes, you're going to see a mulch effect immediately, thankfully. So you put down mulch, you're going to get less surface evaporation, more water uptake for plants. But in the long term, you're also going to see reduced soil compaction, improved aggregate stability, improved water holding capacity, and it really promotes root exploration and water nutrient uptake. So, this is important to couple this with low disturbance. So if you put mulch on the soil surface, it's good to just leave it there as long as you can, and then you'll be able to see some benefits around soil structure and water dynamics. And last at the bottom, thinking about these different microbial components of soil health if you apply organic matter amendments. Again, this is broad generalizations, but typically you see increased soil bacteria at first in the shorter term, perhaps within a couple years. If you mix it into the soil, that's going to have different effects than if you just put it on the soil surface. But generally, you're going to see increased soil bacteria. And then generally a little bit later, you're going to see increases in soil fungi. And then in the long term, you'll see increased microbial diversity and multifunctionality. So this might be more details than you really need on a practical basis, but the point really here is just that you can get so many different types of benefits from organic matter amendments in soil health. They happen at different rates and different timescales. But again, they're all ultimately interconnected and affect each other.